Hi guys, today we're going to learn about the geometric series test, the term test for divergence, and the telescopic series test. So the first one that we have over here is the geometric series test. We say that series is geometric when we have the form the summation from n equals 0 to infinity of a times r to the power of n, or the summation from n equals 1 to infinity of a times r to the power of n minus 1. Also, you can have something that looks like this, the summation from n equals 1 to infinity, and you might have a times r to the power of n, where a is going to be different than 0 and r is what we call the common ratio, and you learned this in pre-calc, the common ratio, okay? So the geometric series test tells you that it diverges if the absolute value of r is greater or equal than 1. If the absolute value of r is less than 1, then we say that the series converges. And more specifically, it converges to the sum that it's going to be equal to the first term divided by 1 minus the common ratio. So let's look at a few examples so you can see that it's pretty simple. So if we start here, we need to determine whether the following series converges or diverges. We have this one that it says that you have the summation from n equals 1 to infinity, and we have that the function here is 3 divided by 2 to the power of n. Okay, so the way that I see it is better than this. Okay, so because for me that's not clear what's going on, but if I convert this into 3 times 1/2 to the power of n, it's more clear for me that this is indeed this is a geometric series, and it's in the form a times r to the power of an n, okay, that we have over here. Okay, so now you can see that it's a geometric series. What's the next thing? You recognize that r is equal to 1/2. Moreover, what we have is that the absolute value of r, which is the absolute value of 1/2, this is less than 1. Since we have that it's less than 1, we know that this is the condition that we are meeting. Therefore, we can conclude that the series converges. Okay? So since this is happening, we can conclude that thus, okay, my series from n equals 1 to infinity, 3 divided by 2 to the power of n, converges, okay, by the geometric series test. Okay, and that's pretty much it. Okay, so you always need to find the absolute value of r and compare it to 1 to conclude. Okay, the next example that we have over here, it's a little bit different. This series, it's clear cut that it's a geometric series because you can see the 3/2 to the power of the n. So you can recognize immediately that this is a geometric series, okay, and you can see that r is equal to 3/2. Moreover, what you have is that your absolute value of r is the absolute value of 3/2, or 1.5, and clearly this is greater than 1. Therefore, since this is greater than 1, you know thus, okay, your series, which is from n equals 1 to infinity of 3/2 to the power of n, diverges okay, by the geometric series test. Okay, and that's what we have so far. Okay, so for the next problem, what you have here is that they are asking you the value of the series from n equals 0 to infinity of -2/3 to the power of n. So what are you going to do? First thing, you will recognize that this is a geometric series, okay? Second thing, you see that r is equal to -2/3. After that, what you have is that the absolute value of r is equal to the absolute value of 2/3, which you can recognize that that's less than 1. Therefore, what you can conclude is the series, okay, converges by the geometric series test. Okay, so after that, you're like, well, that's great, but that's not what they are asking. So what are they asking? They are asking about the value. You are like, well, I can find a value if I find my s. S is going to be equal, s is the sum, okay, a divided by 1 minus r. A, remember, is the first term of your series, and r is the common ratio. Are we okay with that? So with that being said, what is a? A, when you plug the 0, which is the smallest number that you have here, you get that a is 1. So it's going to be 1 divided by 1 minus, and what's r? You have that r is negative 2 over 3. Okay, so from that, what do you have? You have that s is going to be equal to 1 over 5 over 3, which is equal to 3 over 5. And you can see that this answer is C. Okay, you select your answer and then you move on. The next test that we have is the nth term test for divergence. This test tells you that if the limit when n approaches to infinity of the nth term it's different than 0, then the series with the summation of from 1 to infinity of the a sub n diverges. So this does not say that if the limit when n approaches to infinity of a sub n is equal to 0, then the series converges. That's completely wrong. This test only proves divergence. This means that if you have a situation where the limit of n that approaches to infinity of a sub n is equal to 0, then the test will not tell you anything and it's useless, and we need to use another resource to conclude. Okay? So determine, let's go to the examples. Determine whether the following series converges or diverges. So clearly you see that this series, it doesn't have the form of a geometric series. So we need to do another test, and the test that we have here is the nth term test for divergence. So let's do it. You know that the nth term, okay, the nth term is going to be this guy. Okay, this is not the series, this is just the nth term. Okay, so we're going to take the limit of that guy. Okay, that's a guy that it's individual, you can see it, it's this. Okay, so you take the limit of this equation. Okay, with approaches that we have seen before, you know that I can divide the numerator and denominator by the highest degree of the denominator being n, okay, to the power of 1. So I divide everything by n. So you see that we're going to cancel a lot of things. Okay, so these two cancel, this goes to 0, this goes to 0. So what I have here is a 2 over 3. Okay, this 2 over 3, okay, is different than 0. Okay, since this is different than 0, what I can conclude is thus, okay, we have that the series from n equals 1 to infinity of 2n plus 3 divided by 3n minus 5 diverges by the nth term test for divergence. Please note something. It's very important that you are telling the reader the test that you are using, because this is the second test of many that we're going to learn. So it's very important that you tell the reader what test are you using, okay? So they know how your work and how your mind is thinking, okay? So the next example that we have over here is the summation from 1 to infinity of n factorial divided by 2 times n factorial plus 1. And we're going to take, remember, the nth term. So the nth term, just that term, we know that it looks like this. Okay? So if it looks like that, we know that we can take the limit of that term. Okay? Which is n factorial divided by 2 times n factorial plus 1. So similarly to the previous example, what you're going to see here is that when I want to find the limit of that, the highest degree of the denominator is n factorial. Okay? That term, that it has the n factorial. Okay? So I'm going to divide my numerator and denominator by the n factorial. So what you have here is n factorial divided by n factorial divided by 2n factorial divided by n factorial plus 1 divided by n factorial. Okay, so this cancels, and that's a 1. This one goes to 0 because this is 1 over infinity, and this cancels, and it's a 2. So summarizing, what you have is a 1 divided by 2 plus 0. So this is a 1/2. which you know that that's different than 0, therefore we are very happy because we can conclude. Thus, your series, okay, n factorial divided by 2n factorial plus 1, okay, diverges, okay, by the nth term test for divergence. Okay, so that's what we have so far. Now, the last example that we have for this test in this section, okay, is this one. What are you going to do? Okay, so again, you take the nth term. Okay, the nth term is this guy, right? Okay, so that's my nth term. Okay, so you're going to take the limit of that guy again when n approaches to infinity. So what can you do there? What I can see that I can do, I can split this. Okay, well, I'm going to rewrite it like this, and then I'll tell you how to split it. Okay, so you have this. We can split that fraction into two more friendly fractions. Do you agree with that? So this is a 1. So you have that that's a 1. This goes to 0. So you have that this is 1. 1 is different than 0. So again, thus what's the business here? My series, okay, this beautiful series that we have diverges, okay, by the nth term test for divergence. The next test is the telescoping series test. A series such as this one, you have that 1 minus 1/2 is the first term, then 1/2 minus 1/3 is the second term, and the third term is 1/3 minus 1/4. So what you can see here is that I can start canceling terms, okay? And this will cancel with something here. This is called a telescoping series because it collapses to one term or most likely a few terms. If a series collapses to a finite sum, then we say that it converges by the telescoping series test. Let's look at some examples. Determine whether the following series converges or diverges, and you have this series from 1 to infinity, and the function there looks like this: 1 over 2n plus 1 minus 1 over 2n plus 3. So what are you going to do here? What you recognize is that this series is going to be, when you plug the 1 here, you have that 1 over 2 plus 1, that's 3, minus 1 over 2 plus 3 is going to be 5, so that's your first term. Your second term, when you plug the 2, you have that it's going to be 1 over 5 minus 1 over 7. Okay, when we plug the 2 here, because that's a 4 plus 3. Okay, the third term you can see here that the third term is going to be 1 over 7 minus 1 over 9 plus ... up to infinity. Okay, so but that you can recognize that here the telescoping pattern is appearing. Okay, so eventually we're going to keep this one and more. Okay, what's the more thing? Okay, if we do the partial sum up to the nth term, okay, what you have is the following: 1 over 3, which is the first term, okay, plus the second term that we have over there, okay, minus 1 over 7, ... up to what? Okay, the last two terms. The last term that we have here, you know that since it's the nth term, you know that it's 1 over 2n plus 1 minus 1 over 2n plus 3, okay? So what you can see is this will cancel with this will cancel with something here. If you want to plug another one, this is going to cancel here, and you know that this one will cancel with something here. So this is my first term, okay? This is my second term, okay? And this is my nth term, okay? That part of the nth term is going to cancel with the nth minus 1 term, okay? This part, I'm going to keep this and this. So you know that the sum, the partial sum of the first n terms, what you have here is 1 over 3 minus 1 over 2n plus 3. What this test is telling you is find the limit when n approaches to infinity of the partial sum of the first n terms, Okay, if that gives you something, which it does, because this is going to be, this flies to 0, this is 1/3. So since it's finite, okay, you can tell that it's finite. You can say that thus your series 1 to infinity of 1 over 2n plus 1 minus 1 over 2n plus 3, we can say that this series converges, okay, by the telescoping series test. Okay, and this is a test that only works for converging series. Okay, so you cannot say anything about diverging, but if it's finite, you can say, meaning this one gives you a number, then you can say that this is converging by the telescoping series test. Okay, the next example that we have over here, what you have is that the summation from n equals 1 to infinity of 1 over n squared plus 3n plus 2. So you're going to tell me, what in the world is this? This one, it doesn't look like a telescoping series. Well, first, does it look like a geometric series? No. Now, if you apply the nth term test for divergence here, what you can see is that immediately this is going to 0, so it's inconclusive. So you cannot conclude anything. Now, the third test that we have, which is the telescoping series, must work somehow. So let's manipulate the situation. The first thing that I see, I look at my denominator and I'm like, hey, I can factor out that denominator. And you're right. We can factor it out as 2, like n plus 2 times n plus 1. Okay, so you have the situation. This, you're going to tell me, now what? Well, from integration, you remember one of the most interesting ways of integration, which was partial fractions. So this one, you can decompose this as a partial fraction. Okay, plus b divided by n plus 1. Okay, cool with that? Now, if we have that, you know that it's 1, because this is a 1, and you remember with partial fractions, you have a times n plus 1 plus b times n plus 2. From here, we had a mini system of equations, which was a plus b, it was equal to 0, because you know that the n, you don't have any n term here, term with the n, therefore it's 0, and then you have that a plus 2b, okay, 2b is going to be equal to 1, because that's the constant term. Do you see it? Here. Okay? So this is your system of equations. Using elimination, you can see pretty neatly that b gives you that it's 1, okay, and a, it gives you that it's negative 1. Okay? So with that being said, you go ahead and you change, let's say this 2, okay, for your value. So this is negative 1 and this is 1, right, from the information that we have here. So you can now see the telescoping pattern. Now, you want the partial sum of the first n terms. So what are you going to do here? Well, you plug, the first number that we have here is 1, so you plug negative 1 divided by 3, okay, plus, and then you have that it's going to be 1/2, plus, and then you plug the 2, which you have negative 1 divided by 4, plus 1/3, plus dot 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 dot. You know that at the end of the day you are going to have your n term. This is the first term, second term, okay, right? And this is, let's say the nth term, okay? So the nth term, what you have is that you have that it's going to be negative 1 divided by n plus 2 plus 1 over n plus 1, okay? And you're going to tell me, so which one of these two is going to cancel out? It's pretty clear that this cancels with this, and this one is going to cancel with something in the middle. But what's the business here? Well, what we have is that you are like, I'm wondering which one. You can say that this one will cancel, but if you are not sure, what I do is I also do the nth minus 1 term, okay? So if I plug the n minus 1 here, what do you get? So if I plug n minus 1, you have that it's n plus 1. And n minus 1 here, you have that it's 1 over n. So what you can see is that this guy cancels this one, so you're going to keep this one and this one. So when you compute S of n, you have that S of n is going to be 1/2 minus 1 over n plus 2. Meaning that when you get the limit, either way your limit, it was going to be 1/2 no matter which one you choose from these two. But, I mean, you want to have it correctly, okay? So you know that this is going to be 1/2 because this flies to 0, okay? So again, check mark. So what happens here, what you have here is that, again, thus your series from n equals 1 to infinity of this series n 1 divided by n squared plus 3n plus 2 is going to converge, okay, by the telescoping series test. And that's pretty much it. I hope that you find this video helpful. Bye!